See me. I had
Good
to,
evening.
I had to rush and get something out to you guys. I don't know if you saw it. Did anybody get a special message from me?
Yes.
Yes. Uh, well, I can pull up my list. Maybe I should. Hold on. All right. Should be printing any second here. So, Rosio, you got it?
Yes.
Okay.
I got it.
How about Holly? Holly, are you there?
Yes, I'm here.
Did you get the message?
Yes, I did.
Joshua.
Sharon.
Well, Joshua. Edith, are you there?
Yes, I got it.
Okay. Lexa Fernandez up there. Hunter. Did you get it? Lillian Holmes Hancock.
Yes, I got it.
Okay, you guys. Let me tell you what it's all about. If you do the problems and submit them to me, you get on your final grade between 1 and 3 points added. So I mean, it's not my choice, it's the school's. They selected you at a random. And uh, if you, without telling you the answers, I can tell you how to think, and that will give you the answers. You have to think in terms of the world as it is today, with inflation, with costs going up, and that if you finish your education early, you will save yourself money and you'll make money. Why? Because you already have your degree. And so the tuition today is going to certainly be cheaper or not more expensive than next year. And with a degree, your value to whatever company you have should go up versus go down. Now, let me see if I can bring it up. The message. Or can someone just send me the message I sent you? One person, that'd be great.
Dr. Wickman, this is Erica. You didn't call my name. And I didn't get the email either. So was it not for everybody?
No, it wasn't.
Okay.
I just forwarded it, Dr. Wickman.
Who was that?
Rosio, I just forwarded to you what you sent us, not even that long.
Let's see if I got it. I'm looking. Yes, I do. Mm-hmm. We look here then. Can you all see what I've opened up here?
Yes.
You see where it says Math Core Assessment 21 in year 22? Can you all see that? Can anyone see it?
The assessment didn't come up. We see your email.
Hmm. Let me see what I can do. It's kind of unusual. Oh, heavens. Darn. Let's see. Yeah. Now you should be able to see it. Can you see it now?
Yes.
Okay, so I'm just going to go over it quickly because there are some here that are alternates. You don't know it yet. Okay. So it's all based on these figures right here. Figure 1 in red says time is money. Figure 2, the fewer classes you take, the longer it takes you to complete your degree. Figure 3, costs go up, they don't go down. Using all that, answer the questions as best you can. There is no right or wrong answer. There really is, but you won't get penalized. Are there any questions amongst the folks selected? If there are, you can always contact me, but you can work together too.
Excuse me, sir.
Okay.
Sir, I could not get the email of the assessment into my inbox.
Who is this?
I'm sharing.
Oh, it didn't get sent to you.
Yeah, I didn't get it.
Yeah. So you weren't selected by the school. A computer selects folks.
Oh, really?
Nothing. Yeah, it has nothing personal. They just, I don't even know. They just send it me a list. All right.
So what is the criteria of the list?
I don't know. I really don't. Oh,
Okay, so if we're understanding correctly, not everybody in this class received the email, just a select few.
that's right.
It's good to know about that because well, I didn't get it, so I was not
I
understanding what's going on. Yeah.
the criteria is you have to be in my class, and then they selected 5, yeah, or 6.
The top five, or
Computer generated.
okay, perfect.
All right. Well, that's it. Um, let me go back. And I again, I don't select them. I appreciate you doing them. the school wants to see if students are learning beyond the books. Some common sense questions. All right. Let me get my papers together here and we'll go forward. But that's what took me a little bit of time to do that. And of course, I have the list printed out. And the reason why I did it for everybody, because there are other alternates, your name may be called upon. So I did it for everybody, plus it's recorded. Plus I was hungry, eating grapes at the same time. All right. I'll start doing attendance. Sharon, are you here?
Very good evening.
I got you.
I'm all here.
Amanda? Amanda was here. Are you
I'm here.
Amanda?
I'm here. I'm just having a problem with my computer.
I
I'm
have
good.
problems every day. I got you, Amanda. Dylan. I guess Dylan's here. I got a flag on him. Do I? Dylan, are you here? Oh, yeah, there it is. Edith? Edith, are you there? You were. Come in, Edith. No, Edith, okay. How about Emma? Emma Leverett?
Yes, I'm here. I'm sorry.
You guys are slow to respond today. Hope everything's okay. Next, is Erica Whitehead.
I'm here.
Good deal. I got you, Erica. How about Gabriel Mulvaney? No, Gabriel?
Right here.
Okay, got you, Gabriel. Holly, are you there? No, Holly? How about Hunter? I know Hunter's here. Indira?
Hi, I'm here.
And Mark, you in? James, excuse me, Nikki?
Here.
Gotcha. Let's see, who else? Lillian Holmes Hancock?
Yes, I'm here.
Gotcha. Lillian, are you okay? Lillian, are you there?
Yeah, everything's
I
okay with me.
Because we missed you for a lot of classes, right?
Yeah.
All right. Marissa Flores?
I'm here.
I got you, Melissa. Let's see. Monica Hickson. Monica Hickson, yeah.
I'm here. Hello. Here.
Okay. How about Reba?
I'm here.
And then I have a Rebecca.
I'm here.
Okay. Rosio
Here.
and Vanessa. All right. Today we're doing sequences and summation of sequences. This is unique stuff. Let's see what I have. Get us here. Put us back into the book. And I believe we're going to be on 8.1, doing the last parts of the course. By the way, it seems unusual maybe to some, but the last three classes or 4 classes will contain 70% of the test material. So just thought I'd mention that. So it's very important you attend, and this is the harder stuff. All right, let's see. Might be a little too big. And there we go. All right, can you all see the book now?
Yes.
Very good. Okay. This is the Fibonacci sequence. It's very, very famous. In fact, a lot of people think that it is a divine sort of concept. You see, what you have on the right is like a sunflower seed. And the expansion of that seed goes by a sequence known as the Fibonacci sequence. It's kind of an unusual sequence, but there's a mathematical organization to it. The piano, it says the numbers in the Fibonacci sequence are in the octave concepts of the piano keyboard. You have a 2 black, and then you have 3 black, and then you have 5 and 8 and 13 and so on. So if you look at in the middle of the page here, it gives you kind of a concept of how the domain and functions go or ranges go for the sequence. For example, for the first number.
I'm sorry, Mr. Wickman, we can't see the book. We just see the chapters.
I thought someone said they saw the book.
No,
Okay.
what I see is chapter, the little pages.
Thank you for
Yeah.
sharing that with.
You're welcome.
Can you see it now?
No, the screen is black. There it goes. Okay, you're good.
Okay, so look at the piano. That's the Fibonacci sequence there on the keyboard, 1 octave. Look at the numbers above you. The sequence shown 1, 1, 2, 3, 5, 8. Look how it's developed. You have 1, and then you start out with another 1, and you add those together, you get 2. 2 plus the 1 before it gives you 3. 3 plus the 1 before it, which was 2, gives you 5. 5 and 3 is 8. This is all the sequence. So it's pretty neat. Now, if you look at the blue bubbles, the bubbles start out with A1, that's term 1, A2, which is term 2, A3, and so on. They're the nth terms. So the nth term would be whatever one you're looking for. It's important so you know how to use the formulas. Again, thank you, Rosio, for forwarding that document to me. Now, here is the first example. Let's see. I don't think you can see it all. Let me get my, let's see if this will help. Nope. It's not coming up. I want you to see the whole thing. Let's try that. Can you see the whole book now?
Yes.
Everyone?
Yes.
Okay. So some of these sequences will be easy. Some of them will require you to write down the formula. And to do the formula is hard. Could someone mute their machine, please?
Oh, I'm sorry.
So if you look at the first one, it says a to the n, that's the term you're trying to find, is 3n plus 4. And they want you to start using the numbers 1. So if you put 1 in for n, you get 3. 3 plus 4 gives you 7. And you can see the first term then is 7. Then you put 2 in. 2 times 3 is 6 plus 4 gives you 10. So the second term is 10. And then you put the 3 in, is 9 plus 4 gives you 13. And you can see the sequence goes up by how many every time? 3. That might seem kind of oxymoron, since it's plus 4, but it really only goes up 3. That's because of the multiplication process. Some of these you can look at. Let's go on example 2. Now we're going to use a recursion formula. Let me check on one thing here for us. Using recursion formula, it generally means you have a formula and you put the numbers in from one number to whatever it is. So the example says find the first 4 terms of the sequence beginning with A1 equals 5. Well, this is an important point. The first number they give you is the first answer. The first, so you really only have to find 3. Why? Because 5 is given as the first term. Then you plug 5 into the equation, and you can see it right here. So 5 times 3 is 15, plus 2 gives you 17. So 17 becomes the second number. Then 17 is plugged in. 17 times 3 is 51, plus 2 gives you 53. And that becomes the third term. The fourth term is 53 times 3, plus 2 gives you 159, plus 2 gives you 161. So the first 4 terms of the sequence are shown. Now, let's see if we can find something in our calculator. Some of us will have those on our calculators, and some may not. Let's see if I have it. I'm looking here. Yes. So let's go to our calculators for a second, because this will be really helpful for what we're doing. I'll pull up my calculator here. See if I can turn it on. And you all will need to do the same. Now let's go to math. You should have a number called 10. Let's see if this one does. It may not. It does. It has a summation notation. Let's hit that. If it gives you this, you have a great calculator, and life will be good for the rest of this course. Does anybody have this on their calculator?
Yes.
Yes.
Okay. If you do,
What did you
this.
click?
Pardon me?
Excuse me, sir,
Yes.
but I couldn't have the matrix one, but I have the summation.
Does it give you this?
Mhm.
Okay. So to get there again, I think someone didn't know or asked again. We're going to go to math right here, and it should be number 10. There it is. Summation notation. Hit enter, and boom. Now, let's do this. Let's put a summation notation up here. The number down here will be where it starts out. We'll say, it'll say usually some number like n equals 1. We'll write x equals 1, and we'll go to 5. And we want them x squared. So let's see if we get the answer we're looking for. You can see what we wrote. X squared is called the expression. We'll go to our calculator. It says here A. We can say X. We can say 1. Push it up, and we say we're going to go to 5. And then we're going to say X squared. And I'm going to hit enter. And it gives us a syntax error. What was? Oh, we didn't have X in there? Did I not hit X? Was that not in there? Let's see if that there a problem. Yeah, well, I don't know what happened. I thought I hit X. Maybe I didn't. So what that did is it took the numbers. Well, you see the answer is 55. Here's what it did. It took 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared and added them all up and got 55. So this is 1, 4, 9, 16, 25, and it gets 55. So the calculator will do that for you. I gave you an easy one so you could calculate it manually and see how this works. Did anybody get this?
Yes.
Okay. Good deal, Lillian. Now, let's go back to the book. This is factorization. Your book also, or calculator does this too. Notice that 0 factorial is 1. 1 factorial is 1. Now, what does a factorial mean? Factorial is this. Sharon, you have your hand raised, and maybe you could lower it. It's coming on every time. Thank you. So let's say you have 5 factorial. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Now, one of the techniques is if you have 5 factorial over 7 factorial, we know the top's going to have 5 times 4 times 3 times 2 times 1. The denominator is going to have the same thing, except for it's going to have 7 times 6, and then times 5 times 4. These can cancel. So you have 1 over 76, which is 1 over 42. Now, let's show how to do this with our calculator. Let's see here. So let me first of all show you where it is on your calculator. Here's my calculator back up again. And I think we got to go to stat. Math. Yeah, math. And you got to click over to probability. And there it is, number 4. Now, if you hit that first, enter, it won't work. It gives you, it doesn't work. So if we want to do 5 factorial or 7 factorial, we just hit 5 first. Then we go to math. We go over to probability. I'll just hit the number 4. Boom. You have 5 factorial. Now, let's do this problem. Let's do 7 factorial. So we're going to do 7 factorial. Go to math. Go over to probability because that's where it is, number 4. And we're going to divide this by 5 factorial. We're going to do the reverse. So do 5 first. Math. Go over to probability. Hit number 4. Boom. So we end up with 42 because remember the 5 cancel and you have 7 times 6 left at the top. So all this will be here on your calculator. Now, you might say, well, I can easily do all this, Dr. Wick. I don't need this. On the test, they will give you some that are very complicated. Let's say you do 9 factorial or 11 factorial. Now, you can sit there doing 1 times 2 and adding them all up. Sure as you do that, you'll make a mistake. But if you just know how to do this, life is good. Just got to go over to probability, hit number 4, shows up, and then boom. $39 million. 916,800. Now back to the book. We have just introduced ourselves to factorial. Now, we're still doing basic things using sequences. This time we have an exponent. So you put 1 wherever the n is. And that gives you the a to the n term. So I said find the first 4 terms using this. Now, let's see. 2 to the x over parentheses. X minus 1 factorial. And they want us to find the first 4 terms of this. Well, if you put in 1, follow the rules. 1 minus 1 is 0 factorial. You get, and if you look at all of these, you'll get the terms as you see there. Now, if we're going to add them all up, you'd have 2 6, 10, 11, 12, and 2/3. So that will do that for you. All you're doing is plugging in the numbers wherever the ends are. It gives you the first 4 terms. Now, it doesn't ask you to add them all up, but if it did, you could use a summation sequence. And we'll do that, but not here. Next problem. Numero quattro. 10 factorial over 2 factorial, 8 factorial. I'm a calculator guy. I'm using my calculator. Stop. I'm going to go to my window and find my calculator. Clear it. I'm going to put 10 factorial because that's what it said to do. Go over to probability, hit number 4, boom. And divide it by, I'm going to use parentheses because there's 2 parts to this. 2 factorial, go back over to math, roll it over to probability, hit number 4. And then it said it wanted to multiply it times 8 factorial. And again, we go over to math, slide over to probability, hit number 4, then close our parentheses, and then hit enter. That gives us 45. Now let's see what the book says. The book says 45. I would always use it. All right. Number 5. I kind of note this one because it's kind of interesting. I don't know. Anybody out there have children? A couple of you all have children? Well, whenever you have a child, when you ever have children, you kind of think, wow, man, these things are expensive coming out. As soon as I get finished buying these diapers, they get toilet trained, they won't have that big problem anymore. But then you get different clothes and you got to buy. And nowadays at 5 years old, they got to have a cell phone, I think. You know, it's weird. It doesn't get cheaper. That's what the point is. You think it does, but it doesn't. And it shows you here the first year, the cost of a child. This is way back when, I don't know what year this book was, probably 2019 or 18. Things are not cheaper. The cost for a child for food, part of your house, part of electricity, more gas, $10,600 on average. When they become 1, it goes up another $330. Then 3, wow, they get even more expensive. This is what it costs per year. So if you look at the first 9 years, you're looking at what, $90,000 or more. And when you get older, you spend, it doesn't matter, I guess, how old you are. Your children still are important to you. Keep spending more money. Look at that. Look at age 13, 16,000. Age 16, 18,000. That doesn't even include school stuff yet. Anyway, this is just something to point out. Now, there was a formula for this. Look what the total cost was. From age birth to, I believe, 18 or 19, $260,700. Let's see what it says. Excuse me, 18. From birth to 18, you're spending mucho dinero. Now they show you the summation notation. They use I, my calculator could use I, but I use X. That's the first term. 18th is the last term. And remember, a to the ij or whatever it is it called the expression. So what we want to do is practice using one of these. So the first one, they want us to square all the numbers, then add 1, and then add them all up. So if you wrote down what we want, we can go to our calculator now. Well, darn. Here it is. Gosh, I'm lucky I looked at that. My calculator, my computer just became unplugged. That's not good. There it is, back in. Thank goodness I had a little battery left. Can you all still see my calculator? Are you there? Thank you. So I'm going to go to the summation notation. Remember, we go to math. We go all the way down to number 10. There's summation notation. We hit enter. We're going to use x as our term. So that's x. Let's see if that did x for us. X, there it is, our term. And then we said we're going to start with number 1. And we're going to go up to 6. So we're doing the numbers 1 through 6. The expression, if you wrote it down, was in parentheses. Instead of I, we're using x, remember? So we're going to use x squared. And then we're going to put in the plus 1. And push it out. And now it's going to put all the numbers in there from 1 through 6, then add them. And we'll get 97. Did anybody have any success in that?
Yes.
Only Lillian out there? Did anybody else get it?
I get one.
No, I got an error.
Let's go look at that, Amanda. Look at mine. Did you put x equals 1?
I put x squared plus 1, so I need to somehow delete a little box that's appearing by my 1.
Yeah, push it to the right. Push it out of it. You want me to do it again with you?
Yeah, thank you.
Okay. So I'm going to go to math. I'm going to go to 10. I'm going to go the easiest way. Enter. So I have this. Do you have this?
Yeah, it's just I hit a button and I don't know how to delete, I guess. But
All right. Well, we'll practice. Here's the x. And then this one's the number 1. You got that with me?
yep.
I'm going to push it to the right, and it pushes it up top. Did you do that?
Yep, I'm there.
I'm hitting 6. I'll push it to the right again and puts it in the box. You with me?
Mm-hmm.
Now don't do this. I'm going to put in 9. Oh, I don't want 9. So I'm going to go back and just write over it. I'm going to write over it in
Okay.
this. So, and I'm not going to use I, I'm going to use x again. I'm going to x, upper arrow, squared. Then I have to push it out of that box forward.
Yeah,
Plus
I got it now.
1. Yeah, okay, good deal. All right. That's good to hear. And it's just a matter of getting used to your calculators. Some have different ones. There are 5 different calculators methods to do this, all in the same calculator, by the way. I used to know all 5. Painful. All right, let's go to number 6. Number 6 says, express each sum using summation notation. Well, what they want you to do is design it. So let's look at A. They're all cubed. It starts at 1, goes to 7. We'll look at the answer. The first term I equals 1. Top is where it ends at 7. An expression is cubed. Every one is cubed, so it's I cubed. Now, most of y'all don't have I in your calc, you use X. But the book uses I. It's the same thing as X, so I hope that's not confusing. And the same thing for the expression that you see for B. Summation notation, N goes on the top because it goes on and on and on forever. Starts at 1, goes forever. Then you have 1 over 3i minus 1 as the expression. Let's get 7. Okay, so this stuff gets like this more and more. Next class will be even more complicated, but not as many problems. I say that, but it's more complicated, but yet not hard if you might consider looking at it in advance. So our next class on Wednesday will be arithmetic sequences, then geometric sequences, the binomial theorem, and that's good because that will cover everything. Some of the other classes don't have enough time to do binomial theorem, and they have that on the test, and I hate to see students not get that right. Let me go back to my attendance, make sure I've got everybody accounted for. I've noticed some people have dropped off, and maybe some people have come on board, and I try to keep you guys no more than the time of the class or a little bit less. So try to prepare these lessons so that you can just feel like you're getting the meat of the stuff. And of course, me eating grapes. All right, so let me see who I'm missing here. Ryan, did you ever make it in, Clouch? Oh, Ryan. Lexa Fernandez, a bowling lady. Nope. How about Alma Garcia? Usually comes. Okay. Jordan Guerrero. No, Jordan. Let's see, who else am I missing? Maybe. Everybody there. Last page. Vinicio. Joshua, you came in, right? Joshua Trejo. Did Joshua make it in? Nope. And then I have everybody else accounted for. I appreciate your patience. Man, it's getting cold out there. I think winter's got us now. Thank you all for paying attention to me and hopefully learning a little bit. And thank you for those who are doing those core assessment things for me. I'll say good night to everybody then.
Thank you.
Good night. Thank you. Good night.
Thank you
Good
very
night.
much. Good night.
you.
Appreciate it.
Good night.
Again, a good group. Thank you all.
Thank you very much.
Bye, Sharon.
Mhm.
See you,
So,
Dylan, Gabriel, Hunter, Marissa. See you guys.
You have a wonderful night.
Thank you.
Great to
Night
have
Hunter.
you as our teacher.
Thank you, Shane. See you, Monica.